So let me just introduce myself first. My name is Sheriff Ponso, and I'm a senior lecturer at the School of Civil Environmental Engineering, and I'm also one of the CIC's project. So I'm very lucky to be engaging with most of the researchers here. So hopefully we can work together a lot of common areas in the future. So today's summit will be conducted in two sessions. And after the first session and second session. First session, I will be introducing, the moderating the session, and we have 5 speakers. And the second session, after the tea break, my colleague, the presentation, will be moderating the session. So we have just a few housekeeping for the speakers. If you can limit your presentation to 15 minutes, 15 minutes, but 10 minutes for presentation or 5 minutes possible for question and answer session. So we have a little bit more for our keynote speakers and the first speaker. And after 10 minutes, I will give you a reminder so you can wrap up within 2 minutes so that you have at least 3 minutes for question and answer session. So without further ado, I would like to invite Professor Ho Kyung-Sean to speak and update on the hub activities. Just briefly, Professor Sean is head of the discipline of the environmental and water engineering in the School of Civil Environmental Engineering here at UTS. And he's leading several big projects, and this ARC NiCE is one of them. And he's also former future fellow, and also the ARC College of Experts. So his research interests include the circular economy, sustainability, resource recovery, desalination, and water treatment. Please join me in welcoming Professor Sean.
Thank you, John. Hello, everybody. Yeah, good to see you again. How was your lunch? Sorry to hide to play after a big lunch. So if you feel like you're very tired and have a rest, so that's fine. So relax, because my presentation is not too much scientific or technical, just more about what's our next step for the ARC NiCE. We want to have a discussion together. What's the best way to go next to 4 to 5 years? So it will be a long journey. How we can work collaboratively, and then how we can make this kind of opportunity to research translation and commercialization. That's the reason why my presentation more about how we think about the next step of ARC. The outline is the progress, what we have done so far. It has been a long journey. You know, we start to prepare this funding 2020. In fact, 2019 December, and then we applied almost 2 years ago. Then we got successful outcome last year. Then now we have launched. So it's like already 3 years to start this project. It's a very long journey, and very much appreciate. So it looks like one project, even starting is very much takes a long time. So I need your support to make a more successful outcome for next 4 years. And what's the activity we have to do? How we can collaborate? So we have a lot of expertise here. Some of them water utility, like the Southeast Water, and we have also some fertilizer company, OCP, and we have some technology water treatment company, Origin Water. And we have also very much circular Australia, overall concept of the circular economy in Australia. And we have also a lot of student postdoc and how we can work together. That's the best way we have to get together for this second summit. Then what's the next step? So how we can collaborate. So that's my talk for today. So general history, yeah. Successful outcome last year, July 2021. So we have a lot of changes. And then we got the final, industry partner 22. So still, we are discussing with the water research in Australia, water array, Melbourne University, and continue to work with some opportunity with the water array. And we have also some of the industry partner. Still, we can accommodate because we have a little bit of funding left over so that we can match and then we can try to accommodate some more industry partners. So if you want to continue your activity for your research and then you have an industry partner, we are happy to let you in our research help. So we have a little bit of more space. So please talk to your industry partner. We can work together. And few project agreement to be completed. Still, we are discussing with the urban utilities some of the final stage of the this agreement. So it will finish very soon. And some projects already started. So some people already got the funding and then they start the project. Some of them still the last minute to sign their contract. So it's everybody different depending on their industry partner and their program. And we have officially started our NiCE on 31st of July. So first year, in fact, we started 31st of July, and then the launch is now November. And then we have progress report in January and February. So you have to, even though you don't get any funding or any progress, you have to finish your progress in January and February. So there are something you can make maybe literature review or some student recruiting or some poster, research assistant. So there are many ways that we can have a contribution from your progress report. So we have a website. I don't know how many people visited our NiCE website. So you can see your photo. Then please give us a biography and then we can update your information. Also, some of students already UTS and Melbourne University, they have several students, PhD students, but I don't know, other universities have not given any PhD student update or research fellow and research assistants. Please give us information, we can update and then make some more collaborative information we can share. And LinkedIn also, we have LinkedIn, and then if you need any information to share, please let us know, we can promote, such as your PhD student, okay, you want to recruit, then we want to advertise together rather than individual, so that we have a lot of information so we can share to get the best student and best research assistant. So I'm sure that Ibrahim will take care of the next action, how we can recruit the best PhD student for next year. And also we have a toilet day. So this coming Saturday, in fact, the launch was supposed to be held on the same day of the toilet day. So United Nations World Toilet Day is 19 November, this Saturday. So they mentioned about still 3.5 billion people cannot access the toilet. So that, it's like we can also, there are many toilet related figures and numbers. So we can try to utilize this information together with NiCE to give a value of the toilet from our project, and then we can get more aligned with the toilet day. So next year, I'm not sure what kind of activity we can try. So toilet day and NiCE will be a very much well matching together, so we can have a good ceremony. And we planning to have. This is our project. So this is Stefano slide. I just borrowed from him. And this is the value of 1 million ton nitrogen, 0.4 million ton phosphorus, 0.2 million ton potassium. So we import mostly $1.5 billion market. The most of that we just discharge to the groundwater or ocean. Also a lot of agricultural waste, and 25% is exported to the overseas, and 20% we just consume internally, and we can capture some of the fertilizer from here, and we can try to make some kind of saving of our nutrient. So we have planned for Brisbane node, Sydney, and Melbourne. The Brisbane node, so where is the Brisbane node? The N is here, also Stefano, University Queensland, Leo, and then Benedict. So they are the Brisbane mafia. So remember them whenever you visit to Brisbane. So please drop by UQ or Griffith University or USQ. So you can talk to them, and they are planning to organize with the urban utilities and make a public toilet in the possibly Victoria Park, in one of the park, which is the very important for the Olympic next couple of years. And we can try to symbolize this public toilet, then utilize the microbial electroanalysis system, then produce fertilizer to grow their lawn or some of stuff near the park. So that's their project. And then Benedict, she's working on the biosolid, biochar. Then you can also talk to her on anaerobic digestion, biochar, and you can also have a collaboration with them. So Professor Leo, she will work with the Melbourne water and Icon water in Canberra. So she will try to look at the CO2, like the climate change, the downstream impact of this urine, or some overall the climate CO2 impact in their wastewater treatment plant. So if you need any that kind of research area, you can collaborate with the area. Also, Griffith University, the Cara and they will investigate some social, technical, and micropollutant analysis. So they will have that activity, so you can work together with them. And that's the Brisbane node. Sydney node, yeah, we will utilize our building for the University of Technology Sydney. So we have a urine diversion system. So we collect our urine and they produce our technology. And we provide some fertilizer to OCP and the city of Sydney. So if you need any fertilizer to test maybe food or golf courses or flowers, any kind of edible crops or non-edible crops, we're happy to provide, so you can test together. So that's the Sydney node. We will work together. ISA people, they are mainly public perception, education, and that's the design. Dana and Jason will work together for this area. And then we have Western Sydney University, Jeff. He's not here today, so he will work on more soil-related fertilizer impact. And we have a Melbourne node. Yeah, Stefano will make a detail. So Melbourne is working with the Southeast Water. So they want to make a mobile caravan toilet system. So we want to have a mobile urine diversion, urine processing technology. Also in Melbourne, there is one place, a fisherman band. It's like a very big construction infrastructure is going on there. Then the Melbourne University co-located in the fisherman band, and they are planning to have a urine diversion system in their campus in new building. Then Southeast Water was small size of the urine diversion building and system can be investigated from this project. So that's the main project we have. Also, we have Michael Duke. He's from Victoria University. So he will work on industrial wastewater, how we can recover nitrogen, phosphorus. So he will give a presentation today. So we have a lot of dynamic collaborative opportunity in water, a different scale, different opportunity, also different wastewater sources. So please, we can have a more interaction for the future to have a more collaborative activity. So that's the domestic wastewater industry, animal wastewater, anaerobic digestion. So currently we are covering in this NiCE hub to produce some fertilizer and recover our nutrient. And this is the 7 university, 22 industry partners, and 3 international organizations. And this is technology from Stefano microbial electro concentration concept. So they will try to make a larger scale in Brisbane. So we will have possibly 2024. So we will organize the NiCE Hub in Brisbane, so we can have a demonstration. And this is the mobile toilet, the Southeast Water, and the Melbourne University currently working on this planning and negotiating together. So we will have a mobile urine diversion and the technology to produce the fertilizer has been developed for this process. And this is the very latest information of urine fertilizer. So already you have one urine bottle. So this bottle is the second batch from UTS. So you can see the detail, what's the NPK ratio, so nitrogen, phosphorus, potassium, 10 to 1.4, 3.5. So what you have in your gifted, so you have a very detailed, this is diluted from our concentrated budget, but ratio is saying 10 to 1.4, 3.5. So we have compared with the other commercial fertilizer and then some other urine fertilizer. So this is a hydroponic fertilizer, which is the commercial fertilizer. They have a 10 to 3.3, 7.6 NPK ratio. And this is the urine from Europe. They have also some commercial fertilizer from urine. So they have a 10 to 1, 4.3 ratio. Also, this is the urine collected from 2018 to 2020 at UTS. So we just say first batch. So Jade, she collected this information 10 to 0.8 to 0.9. And then this second our fertilizer is from 2020 to 2022 so far. So this is our fertilizer 10 to 1.3.5. So UGOL is the membrane technology from Melbourne University and Brisbane North. So they have 10 to 0.26, 3.3. So it looks like even though there are small change, but overall ratio of the NPK, whenever we produce our fertilizer, it's very much similar to commercial political fertilizer. So we are now trying to produce more quantity, then looking at some application opportunity. So next step, so we need to get together how we can register this fertilizer and certification. Also, we are now producing the safety data set and labeling. That's our next step. We are trying to achieve was demonstrate long-term application. We should prioritize the stakeholder, OCP, or City of Sydney, our utility, Southeast Water. So we want to have a more long-term application of this prioritized stakeholders, and some of the optimization of fertilizer, NiCE mobile toilet also support for 3 nodes for their scale of demonstration. And so we need also public perception and then public engagement. Also, we need the support from the Circular Australia. So we want to work with them because they are covering a very broad range of circular economy, and we are one of the very small nutrient recovery. So in the future, we like to keep working together with the Circular Australia. So that's the next step. We can also PhD student, research assistant, we can recruit. So regular meeting, we are planning to do with industry partners. Also, you can continue to plan. Advisory committee, international committee we have, so we can try to also how we can maximize our engagement and progress report. And last but not least, third NiCE Summit will be held in 7 to 9 May 2023. This time is very much overlapped with the Aussie Water. So Aussie Water will be held in Sydney from 10 to 12. So it's a Wednesday to Friday. So you can come a little bit early. So Sunday to Tuesday to Sydney, and then we can have a small workshop. So during this time, we can have a more broad range of the supply economy. We can have a presentation, not only our nutrient. The nutrient will be the one of the special session, but we can make a little bit broad way of the supply economy related workshop we can organize. That's our planning. So we need to produce a lot of exciting data until next 6 months. Yeah. Also, I'd like to thank you to students and then colleagues, collaborators, and CI, PI, also committee members, and the AIC. So thank you for your attention.
Thank you, Chair. Yeah, in the interest of time, but you can have this one question, burning question, if you have any. Okay, if not, then we can go to the next. Thank you, John. Thank you very much. Next speaker, we have Kate Dowling. So simply to change the Kate Dowling is coming in place of Lisa McNeil from Central Australia. Kate is a co-founder and CFO of the Central Australia Limited, and also a part-time lecturer with the University of Sydney. Prior to joining Central Australia, Kate worked as a banking executive for over 25 years in a variety of senior treasury and financial marketing roles in Sydney and London, with extensive experience in financial markets, balance sheet risk management, and capital management. So Kate has a Bachelor of Commerce from the UNSW, and is also a fellow of the Finance and Treasury Association and a member of the Australian Institute of Company Directors. And most likely, Kate has studied circular economy at the Delft University in Netherlands. So today, Kate will be presenting at the about the circular economy. Kate, thank you very much.
So thank you, Cheryl and Sean, for asking us to speak today. At Circular Australia, you're not getting Lisa, who's much more interesting than I am. You're stuck with me. But so yeah, I co-founded Circular Australia with Lisa 4 months ago, which was born out of New South Wales Circular, which was an innovation network set up by the Office of Chief Science and Engineering, which I think most of you are familiar with. I move this one. There we go. So yes, as Lisa McCann and myself, thank you for that lovely introduction. So yeah, I'm a banker in a room full of, I'm quite intimidated by this crowd, in a room full of academic and research. It's a privilege to be able to present to you today. I would like to acknowledge the traditional custodians, despite having been done quite a lot today, but I think it is important because of their importance in the circular economy. So I guess I'm going to go a little out of order here. So I'm going to introduce Circular Australia for those of you who don't know us. So as I said, we were a circular innovation network, and we've taken that and created Circular Australia out of that. Basically, we were there to bring industry research and government together to catalyse circular economy. And what we found is there's a huge demand for this kind of role, and that we could take this where we're a not-for-profit at Circular Australia, and we could take this into to become an independent national body. So we recently appointed Terry Butler as the chair of Circular Australia, and we're about to release our strategic plan. So some of the recent activities we've done, obviously we did the unlocking the value of organics with Western Sydney Parklands with Sydney Water and UTS ISF earlier this year. We've also partnered with Commonwealth Bank recently. They've partnered with us, I should say, and as part of that we produced a consumer insights report into circular economy, and there we looked at, I think there were almost 6,000 surveys that participants they surveyed into that insights report. We also did a global insights report with Citra and Business Finland, and this is all in the last 4 months, and worked on the innovation in circular economy, smart sensing network, and EPA circular ag launch of case studies of organics and driving productivity. So we've been fairly busy, and that's just in relation to some of the reports that we've produced. We're also currently working on a number of projects with large industry players generally, with corporate and also with government. So our main strategic priorities are providing circular economy, economics and metrics. So we are working with industry participants on helping them define circular economy for their business and developing strategies and implement and measure circular solutions. So the next part is supply chains, so circular ag and supply chains. And we work on supply chain initiatives. For instance, we worked on the hospital plastics initiative to define, pilot and implement new supply chains there, and St Vincent's Hospital was the pilot for that program. So our collaboration is driven through both our projects, where we bring together industry and research to solve circular economy issues, but also through our task forces. So we have an industry, a precincts and infrastructure, and a finance investment task force, which I'm the chair of the finance investment task force, as well as a government task force, which have industry and research participants and government representation. So I'm just going to talk about, so there's the task, I've just talked about the task forces there. So we are, and I'm going to go into quite a bit more detail on the finance and investment task force, because it's the one I know the best, and the sector I know the best. So the finance and investment task force has active membership from some of Australia's leading financial institutions, including CBA, ANZ, ING, BNP, Macquarie, CFC, Mercer, T Corp, New South Wales Treasury, Business Council of Sustainable Development, Deloitte, Pollination, IGCC, RIA, ASFI, as well as we also have engagement with APRA. So we have quite a broad range of participants. At the moment, you might look at that and go, okay, you don't have any of the big super funds or number of the funds in there. And part of that is my background. I'm a banker by trade, so to get in a lot of the banks was easy. But what I also found with the investment industry is the way the investment industry is set up. They already have industry bodies around sustainability, and they also heavily rely on their advisors, so who do a lot of their actuarial and technical analysis for them, so the likes of Mercer. And so for me to start with, in terms of this starting this journey, because in the finance sector we're very much at starting the journey for circular, I felt it was better to start with these bodies that already get the issue of circular economy and are already kind of engaged, and work from there. So the objectives of the Finance Investment Task Force, fair to say when we started up 2 years ago, and I'd ring up the banks and I'd say, we're starting up this circular economy finance investment task force, would you like to join? They said, that's great, but can you just remind me what circular economy is again? So what I quickly realised with the finance sector is that we really needed to drive education was the number one. So the first couple of years, I think it's fair to say, we spent a fair bit of time with presentations on upskilling those institutions through task force presentations and initiatives. So the presentations included everything from government, universities, ASFI, industry participants with examples of sort of CE transactions, initiatives and reports. A lot of those were from the overseas participants. And bringing those guys together to kind of upskill and educate the finance participants. So the next piece we did was obviously allowed us to commission a rapid review, which was done jointly by UTS and UNSW. So Karen Coblentz from UTS, and they looked at the state of circular finance as it stands on a global scale, and then what next steps might be. So that's kind of where we're up to now, is the looking at the next steps to drive, so driving debt and equity investment into circular economy. So now we're looking at how we do that and driving the initiatives. The task force members have been asked to mobilise, and we're asking them to form more working groups to start to look at and define the circular economy concepts that need to be done. I'm also on the technical advisory group for the ASFI taxonomy project, which is a project, there are global projects going on, but there's an Australian-centric one. And it's, so the concept of this is that it will feed into the total sustainability taxonomy that's going on in Australia at the moment, and it will be driven out of the task forces. But I suspect we will heavily be utilising our connections with research to help drive the definitions and particularly metrics. So here were the insights from the rapid review. There were a number, and I apologise, there is also a big piece of the built environment, because the Australian banking sector is heavily exposed to the built environment, be it infrastructure or property. So there was also a whole section on circular economy there. But my experience with the building sector is that they're actually much more up the curve on circular economy than the pure finance sector. So for instance, the REITs, the real estate investment trusts, they are much more advanced in terms of their understanding than the banks per se, or the investment houses indeed. So from the first part of the rapid review, global initiatives are in early stages but rapidly evolving. Generally, the initiatives can be review on circular economy finance. And indeed, someone like ING actually has a circular economy desk in financial markets, and we have a sustainability desk in Australia generally, which does green bonds and sustainable linked financing. But I think that the EU's taken it, is a much more advanced stage. So business model tools are being used by the finance and investment sector, but metrics for circular economy are still very much under development, if developed much at all. And I think that's where we really aim to try and assist in developing those metrics, which are crucial for investment. So I think the thing that probably people need to know, which is not on this slide, but I'll just add it, is that both equity and debt, there's a huge demand for sustainable assets, and they'll pay up for it. So in other words, you can finance much cheaper if it can be labelled sustainable, but there's a lot of worry about greenwashing. So the necessity for credible metrics and science-based metrics of what the industry is looking for, because they don't want to be accused of greenwashing and they want to support, but there's huge investor demand both on the debt and the equity side for those assets. So standardization of circular definitions, metrics and practices will help drive circular finance, because the more faith that investors both on the debt and equity side have in those metrics, the more that they'll be keen to invest in those type of finances. So understanding linear risks is another integral part of managing successful investment, particularly in lending portfolios. So looking at your portfolio of loans at the bank and understanding how the circularness of your investment affects your credit risk. So how linear is it? So therefore, how risky is it that you're going to end up with a stranded asset? So we're getting pretty good at understanding that, you know, a coal-fired power station probably doesn't have long-term lending relationship, but in terms of other linear businesses in the circular economy, I don't think the banks are at the stage of understanding how that impacts their credit risk. Some work was done by Bocconi University, which was funded by some bankers, Santese Impolo in Italy, and they actually established a very clear nexus between creditworthiness of an organisation and circularity. Interesting. I found it interesting because I used to do a lot of capital lending risk management. So assessing and measuring the linear risk is important, and it can be mitigated by adopting a proactive approach to stimulating circular business practices. It can be mitigated by actually building in circular metrics into your credit and capital modelling processes of your banks. This was just about the insights report. So CBA, who's partnered with us, it's a really interesting survey, and it showed a clear demand for change from the consumer. So 64% of businesses want to do more to embrace circular economy, and there's a corresponding heightened focus and demand by the consumer on reducing waste and being able to get the goods and having access to that. So it was quite overwhelming. Particularly interesting for me on this was they cut it by several demographics. They cut it by age demographic, number, regional demographic. And definitely, I think the younger generation are demanding that their products be more circular and more sustainable. And then the final other piece of work another instance was IBCC, together with Mercer, did a report on CE for investors, and they did a discussion paper where they were talking about, this is what kind of thing, how can we look at an investor portfolio for a fund, and how can we look at measuring the circularity of that? What are the sort of things that you might start to look at? How might you assess? So that again is the sort of thing that we want to be able to look at with them, and the sort of thing that we would like to be able to get projects started on. I suspect that from a funding perspective, a lot of the funding for these sorts of things will end up coming from industry, I think, although it'll be heavily regulated by a state outright and government policy, but that is the concept. So that's actually, I'm going to be able to wrap up a few minutes early. That was the main capital report. It is very different to every other presentation that's been done here today, because it is quite heavy on the finance sector. We are doing a lot of other work, as I said, in other industries. So the water industry is obviously a very important one. We've already done a project with UTS and hope to be able to do and are looking at doing more of those sorts of projects. And circularity is another big piece of what we're looking to do. So Niall Blair, who's on our board, is particularly keen on driving that. So we look forward to working with you all in the future. And thank you very much. Does anyone have any questions?
Thank you, Lisa. Yeah. So, we have time for a few questions. Ready?
Thank you. So about the circular economy and interest of bankers and I guess investors, legal funds and all those. You mentioned about this sustainability and this liability in the future other investment. That's where they come to this picture. I wonder, is there any other motivation they may have? Liability is one, but do they see any other business model there than just reducing the risk?
Oh, no, huge. So I think there's a couple. One, the end user is demanding sustainable. So there's several. First of all, there's demand from the end user investor wants to have a sustainable, be able to market that their fund is sustainable. Sustainable funds are because everybody's wanting to invest in a sustainable fund. So there's a marketing element to it. There's a regulatory element to it. So you're going to start to, with TCFD, TNFD, and I plan to expand that to include circular economy as well if I have anything to do with it. So, the regulatory reporting on how sustainable your asset portfolio is, and indeed your lending portfolio as a bank is getting more and more. And, as I said, I've already engaged with APRA. I know the guys over in APRA quite well in terms of driving, they're trying to drive responsible investment from the banking investment sector as well. So it's both from a market demand perspective from their customers, the end investors, as well as a regulatory push. So, they don't actually, and then there's probably the least one that they're considering at the moment is the risk mitigation, because they don't, I don't think a lot of people realise the tsunami that's coming, and I don't think a lot of people realise just how stranded some of those assets are. They do with coal-fired power stations, they get that, but with a lot of other very ungreen industries, they're probably still not totally aware of just how stranded those assets might be and how quickly that.
Any other question? Okay. Thank you, Lisa. Sorry. Okay, let's go to the next speaker. We have Rico from Southeast Water. Just a brief bio of Dr. Rico. He is a research strategist at the Southeast Water, managing its strategic research portfolio. He has more than 15 years of research and industry experience in water science and engineering, with technical expertise and research in water wastewater treatment, desalination, membrane technology, urban biotechnology, and emerging technology. So he is also a fellow and chief engineer of the University of Australia and a fellow of the Royal Society of Chemistry UK. So please join me in welcoming Dr. Liga.
Good afternoon all. I'm Li Gao from Southeast Water. So you probably have heard my talk this morning and are sick of me talking again. So I promise I will be very short and only briefly talk about actual projects we are going to collaborate with the NiCE Hub. And again, probably similar to Professor Sean and Katie, I won't talk too much on the technical side. So, but yeah, again, before I go any further, I would like to acknowledge the traditional owner of the land on which we are meeting. The Gadigan people of the Eora Nation, we pay our respect to their elders past, present, and emerging. So firstly, you probably heard my talk this morning. Southeast Water, we are one of Melbourne metropolitan water retailers, and we provide water, sewage, recycled water service to approximately 1.9 million people in Southeast region of Melbourne. For those who know our area, we cover from inner city of Port Melbourne to coastal Port C and the rural Pekinang area. Yes, we have more than 20,000 kilometers of pipe, 8 water recycling plants, more than 300 pumping stations, and the value of our assets is more than $3.9 billion. So this morning, I have touched on a little bit about why we are so keen to be part of the NiCE talk. So like I said, we have water, we have nutrients, we have other materials, and which they are all significant contributors to the circular economy. And we are facing the pressures of population growth, climate change, water scarcity, urbanization. So we have to do something now. And that's the reason we have built our research partnership with the ARC NiCE. So next, I'm going to talk about our plan. So you probably all know that the NiCE Hub, their work covers the whole value chain from urine collection, urine process, fertilizer optimization, and the end user of the fertilizers. So we actually developed 3 main projects, which also cover different areas. So the 3 projects, the first one is about impacts of the urine separation on the downstream process. The second one is about new process for nutrient recovery from urine. And the third one is, as Professor Sean just mentioned, is about NiCE Loo, which is a futuristic mobile toilet for the technology demonstration. So next, I'm going to talk a bit more details of each of these projects. The first one, impacts of urine separation on downstream process. So previously, there are some preliminary studies. They basically demonstrate if we have the urine diversion, then we will have less corrosion on the sewer pipes. So it's obviously because the urine normally, the pH of urine is normally lower than 7. It's acidic, and we have a lot of salts like chloride, which can corrode our pipes. And meanwhile, the urine diversion can also have some positive impacts on the treatment plant operation. Basically, we remove the nutrients before entering to the treatment plant. We free up the treatment plant capacity, and we also reduce the treatment plant energy consumption. But this is only preliminary studies. What we are going to do with researchers from the NiCE Hub is to further investigate the impacts of the urine diversion on the downstream treatment plant operation. We are also going to investigate the microbial communities and the chemical transformation within the sewer pipe. So the second project is about new process for new nutrient recovery from urine. So these 2 projects you already know. It's 2 well-known processes, URL and YOGO, which developed by Professor Sean and Dr. Stefano. So they are either based on the MBR with the membrane distillation MD process or electrochemical processes. So we are at a very preliminary stage to develop some new process to recover nutrients from the urine, which this new integrated process combined with reverse osmosis, our membrane, and some pre-treatment process like fractionation. So we all know that our process has a lot of advantages. For example, we can get concentrated nutrients. We can also reuse, produce the permeates, and we don't need chemicals. But we also need to control the biofouling and the scaling of the membranes. So we try to do some new pre-treatment combined with some pre-treatment process to control the scaling and biofouling of the membranes. And by the way, we haven't got a good name for the process. Maybe you can come up with some good names. Please let me know or let our team know. So the third one is about NiCE Loop, a mobile futuristic public toilet. This public toilet will combine with traditional human toilet and with a living lab, which transfers the human urine to the liquid fertilizer. And we will build this, and we can use it to support our customer engagement and the community events. We can put it, or we can support the councils like a food festival, music festival, or just put it in a hot spot in the tourism spot during the hot summer. So we hope this is a living lab to research and trial urine transformation to liquid fertilizers. It's an application of treated urine for the urban farming and vertical garden. It's an education center to understand customers' expectation and driving their behavior change. It's a research site to investigate the decentralized urine nutrients recovery system for future scale up. It's an engagement tool to engage local councils, the communities, the agricultural or fertilizer sectors. It will also be an exhibition center to demonstrate our commitment to the circular economy. So I won't talk too much about the technical development of NiCE Loop, which is obviously important. I actually would like to emphasize the customer research components of this research, of this project. So how is our community, our customer community's attitude and behavior to the circular economy? What is the best messaging and engagement strategies? How we can influence social media, and how we can promote the use of circular economy process and materials. And can we test the willingness to pay for the future scale up of the circular economy project, such like this? This is all what I have. Thanks for your time. Like I mentioned this morning, I'm really looking forward to unwrapping the onions of the circular economy with all of you. Thank you.
Thank you. So we have plenty of time for questions. Okay.
So for ammonia, for ammonia pH, you can look at overall gas. So
Yeah, exactly.
how have you considered about the loss that before you apply to it?
You are right, because when you increase the temperature or you increase the pH, the ammonia will become a gaseous ammonia rather than stay in the water. But I guess what our pre-treatment fractionation Yeah, we are at the, I guess, in the preliminary stage. Probably before that, we should try to recover the ammonia before they become a gaseous components. Any other?
Thank you. That's right, I'm quite loud.
That's all right.
Veronica from Griffith here. I was just thinking your questions about, what's social messaging and everything. I think we can learn a lot from, there's a lot of that research done around the recycled water use research and people's concerns were and the methods of investigating those that we can translate across to this project, and strategies on how to get that information and how to design really useful sort of experimental social survey work that elucidates exactly what the messaging should be. And so we do it with good quality and publish more results about that evidence for that that's the appropriate messaging. And we can translate. There's a lot of us that were involved in that around Centre of Excellence of Water Recycling and developing those sort of methodologies. So we can I think that can contribute to social skills project. I'll share that.
This is a really good suggestion, and I think we are aware of that. And you are definitely right. There's a lot of similarities here,
But different.
yeah, but different. Like you said, because recycled water has been here for a while, and the people kind of accept it. Although we are not quite there on the total reuse, but obviously we already widely apply the recycled water. But a circular economy for here, urine diversion and recover the nutrients, I think it's still at the early stage development. There's similarities, but probably there's still a lot of knowledge gaps we can investigate, we can study. But obviously, very good suggestions. We can definitely take that, take the suggestions and keep in mind. Thank you.
Lee, just
Yes,
sorry, I don't have a point. With regard to the, I guess that you talked about the downstream impact of taking urine out of the system. Is there any negative impacts of that from a processing perspective within the treatment plants?
This is a really good question. I guess we only talk about the benefits of taking the nutrients from the treatment plant process, like a free up treatment capacity, and also lower the capacity, and even potentially we can lower the nitrous oxide, which is a scope 1 emission from the treatment process. But obviously, when we do some changes, this may have some negative impacts on the bugs, which we rely on it to treat our wastewater. So there's probably something we still need to investigate and quantitatively analyze impacts on the treatment process. You are obviously right. There are definitely questions here we need to investigate.
Phosphate bacteria, for example, would be one, yeah? Exactly.
Okay, thank you very much, Leo.
Thank you.
I'm going to the next speaker, Dr. Jing Wang, from Beijing Origin Water. Dr. Jing Wang is currently working as Chief Scientist of Origin Water Technology and the Director of Origin Water International Private Limited. And she is also a associate professor at the School of Civil Environment Engineering at School. So prior to my appointment, Dr. Jing worked at the Center for Water and Wastewater Technology in University of 10 years. That has been engaged in research and project management of environmental engineering for years. So please join me in the
Good afternoon, everybody. Jing Wan from Orange Water International, and today I'm going to talk about application of membrane technology in resource recovery. to move to the next. slide. Okay. Okay. Thank you. Resource shortage is a global problem. And once we talk about resource problem, definitely we will think about like how to recover the resource we already actually use. So in a report called the Living Earth point out, as the natural resource by human actually used exceed their renewable capacity by 20%. So if we continue to do our activity like this without any remediation in the future, after 2030, our living standard will decline about like after 2030. So then everybody, I guess everybody think about like use a different way to recover the resource. And as I'm coming from Orange Water, we are manufacturing membrane. So we will focus on the application of membrane technology in water resources. So today I'm going to talk to 3 applications. One in fertilizer recovery, and the second one is about industry wastewater recycling. And third one is it's not very positive, but it's still useful way to recover some lithium from brine and or salt licks. This work actually it's a collaborative project working with Professor Sean's team. So the following data actually provided by Sean's group. I think we know about, we're familiar about this whole process. We just try to use some technology to minimize the smiling during during the fertilizer recovery from the urine. So the key points, the key structure of the unit is a membrane, MBR membrane technology. We have run the unit, I think, for 2 years, and also we have some like a product to it's not quite in the market, but we already use for the laboratory plants. So here's some comparison of the fertilizer with commercial fertilizer and also our product. So from these 3 rows of the plant, definitely the product we actually use from our research is like looks like more leaves and also looks like how to say, it's like there's a leaf rich and also grows very well. So in the next step in the future, we are going to modify the whole process and also just because we to minimize any risk when we use urine fertilizer recover from urine. So I believe we have lots of things to do. I'm sure we can get like all the result we expected. For the next application is talk about industry wastewater recycling. So many industry actually developed their technology and also actually discharge lots of wastewater to the lake or just also some like the water catchment. So even though we have some like a regulation or some standard to limit the discharge of the wastewater into the environment, but actually with the accumulation process. So still have some like wastewater or just pollution in the discharge in the environment. So when we do the industrial wastewater treatment or reuse, it's difficult to control the whole process. That's so many questions, so many problems when we do develop the wastewater recycling process, including technical problem and also the high energy consumption, and also for some like other just also use other resources. So Orange Water, we developed a solution with microfiltration and nanofiltration, also with RO system for the whole process to meet the requirement of those wastewater, industrial wastewater reuse. And the second example we do the wastewater recycling is to produce some byproduct during our treatment process. For example, when we do recovery of lithium from brine, to form the lithium carbonate, we also need to add sodium carbonate. But normally, when we do with salt lakes, we also have some sodium carbonate in the lakes. So we develop that process. We do the lithium recovery. While at the same time, we also produce sodium carbonate. So then we can save money, and also we can actually do the whole process like environment friendly. The next one I'm going to talk about the recycling that like just extract bromine and potassium from seawater. That whole process also like include all the membrane process. So we have the advantage we can develop the membrane especially for industry wastewater recycling. Also, we can modify the whole process by ourselves. The last one I'm going to talk about the lithium recovery. The previous two applications, actually, we really do the job, a positive job to recycle those resources from wastewater or waste. But this one, lithium recovery, actually, it's not that positive. But we really need to fix this problem because we need lithium batteries for our life today. So in this process, we comparing about like lithium mining and extracting lithium from brine. We think about like probably recover the lithium from brine is like more environment friendly, and we probably do not need to damage or just affect the environment around those areas. So these two processes we developed just for lithium recovery. So they have a slightly different. So they also have a different product. That's the actually this is a natural filtration unit we developed especially for lithium recovery. And here's the case study, just the real engineering project we developed in China. And it's not a big one, but it's cover all the technologies we developed related to membrane technology. And here's the larger lithium carbonate project that's extract the lithium from salt lake. We developed the absorbent and membrane and the final product. that's the, all information that I'm going to share with everybody. Thank you for the my team and also Professor Sheng team to provide all the data in this presentation. And thank you for your attention. Thank you for your time.
Thank you, Jim. Thank you, Dave. Right. Yeah, we have been interested in a couple of questions.
Thank you, Dr. Very interesting. I'd like to see the work going on in the industry and application. Fantastic. Just interested about the lithium recovery. Did you talk about you talked about batteries, but is the process taking feed from like battery waste or salt lake or both maybe? You know, can you do you do a similar process?
We only do the extracting the lithium from brine and lakes.
Yeah. Do you think battery waste is going to be a big contribution? Or we still need mostly raw supply of lithium. Like I think the IEA predicts something like 10% of lithium supply comes from recycling, but maybe it could be more. Not sure what your opinion is for the percentage the battery recycling contribute to the lithium supply.
Actually, basically, I think lithium recovery from brine or mining lithium, I don't think it's a positive way. So I would like to do some recycling like from battery. Or, that will be the best way for us actually in the future. But we haven't done anything about like battery recovery recycling work. But I'm sure those kind of absorbent and also the process, I think definitely will consider to develop those applications in the future for the recycling process.
Yeah, no, okay. Good one. Thank you very much.
Yes, fascinating work. Yeah, I'm just interested to understand is there is a peak lithium conversation going on and the whole issue of, I guess, recycling lithium batteries. We are capturing, I guess, that metal and putting it into batteries. But is there a point where, you know, with mining lithium, when it becomes economic to recycle it out of batteries and extract it from brine? Has it been sort of any work done in terms of the economics of extracting currently from the mining side of things? And when is there a peak in lithium moment from mining, and when does that sort of economically make sense to be doing brine extraction and recycling out of batteries, or do we already know that we're doing it? Yes, that's a very complicated question.
Yeah, I understand you mean, but because we only think about, say in China, we have a special concern about like the resource of salt lake. We have salt lakes. Actually, we have a chance to do the lithium recovery from those lakes. I also have some literature review about like mining lithium mining. Actually, considering about the economics, probably the price is not mining lithium is not more expensive than lithium extracting from brines. But for the lithium mining, actually, we will restructure the environment around that area. So that will affect actually people living area environment. Also think probably just damage some economic ecology system or something. So considering about that environment friendly, my opinion, if we really need to have some lithium from our natural resources, I just prefer to do extracting lithium from brine first. Thank you.
Thank you, Sue. Thank you very much.
Thank you.
We have the last speaker in the first session today, Dr. Reza Fahi. Dr. Reza Fahi is currently Associate Professor at School of Civil Environmental Engineering at GTS. And Dr. Pape is a recipient of several prestigious awards in Australasia, Young Railway Engineer of the Indigenous Australia and the Railway Technical Society of Australasia. His research interest lies in the problematic groundwater improvement, soil structure, as well as structure interaction, intelligent construction techniques, and optimization of design and construction of. So Dr. Bezak also worked extensively on major infrastructure projects, including the WestConnex 7-8, Valley Bypass project, and a Brisbane gateway. This journal, Dr.
Thank you, Chair, for kind introduction. I'd also like to acknowledge Cathedral people of Ori Nation whose ancestral land we are meeting today, and pay my respect to past elders, past, present, and emerging. So the type of research that I will be talking, I guess, is a bit different to fertilization, fertilizers, and so on. So as one of the speakers this morning talked, so I'm a civil engineer, and I try to find new techniques to stabilize the foundations of the road, and this is a great opportunity that Sean brought this opportunity to my attention last year, and seems quite promising. So that's in collaboration with CIMIC Group, obviously. So quickly, I will talk about problematic soils, what type of problems you have and what we want to improve. So some of the existing techniques and our proposal, what we have, and also I'd like to talk about some opportunities in addition to what we are doing in case we can do some more collaboration. So obviously we know we always like to construct on top of a strong ground, good quality lands, and but it's not always possible considering the increase in the population and urbanization. We need to construct on lands which are not that pleasant. Some of the common ones are soft clays, loose sands, and expensive clays that if you have got this type of soil under your infrastructure, particularly transport infrastructure, the maintenance cost of those structures will increase, and this is not great for taxpayers. For example, for port construction, the picture you can see here is a land reclamation that we needed to a lot of ground improvement, which is quite expensive, and it can be energy intensive in terms of also use of cement. So soft clays are those muddy, the marshy sort of material that you get, that if you get it under your infrastructure, you end up getting a fair bit of cracks on the road, or even your railway may suffer damage. So generally, if their strength is low, in terms of kPa, kilopascals, less than 25 kPa, they are not good. You need to do something with them. So to avoid the problems you see there. Similar applies to loose sands, such as what you find on the beach, obviously it's loose sand. Around city, you have a fair bit of sand dunes. If you have got your infrastructure built on that, again, you can suffer problems. These are some examples of the common or attractive pictures I put there, which are for liquefaction, that if you have got loose sand there, and there is a dynamic load due to earthquake or trains and so on, you may get a problem. As you can see, a structure stands there, but the ground underneath, unfortunately, is not good. The other problem we have is expansive soils. Some soils, when you add water, they expand. So many buildings, cracks that you see in the residential buildings, 1 or 2 story buildings, is because of that. It's just the chemistry of the clay, that water is a polar sort of molecule, will be attached to the surface of the clay with negative charge and keeps expanding. So these are problems that we have. So in terms of the expensive soils, it is quite common to find it on the East Coast here in Australia, and the picture on the right, what you can see shows that if you have got this type of clay under the road and it's not treated, you will end up getting these cracks there and potholes and so on that all of us we are experiencing these days, particularly after flood. So there are current techniques used to treat those sort of soils that I mentioned to you. some of the common ones, or one of the most common one, is the use of chemical binders. The most popular one is addition of cement, that you can see on the left-hand side here, that there is a truck going, sprays the cement on the surface, or it might be lime, and then there is a roller coming, compacting this material, and then you leave it there, similar to concrete. You can say it sets and becomes strong, and you can build your road on top. Or you may like to, if the problem is deeper, using techniques such as the pictures on the right. We have got a deep cement mixing, that you inject the cement powder or cement slurry, mix it with in situ soil, and create a strong profile, and you build your structure on top. As you can see, cement is one of the common items that we use there, so as a binder. However, we know that there are quite significant challenges in terms of cement usage and production. So it creates a fair bit of carbon dioxide production of cement. And to be precise, 8% of the world's carbon dioxide emission comes from cement production, just cement production. There are a lot of other challenges in the construction industry, but this is just from the cement production. So therefore, there is a great motivation there to minimize usage of cement, and therefore production of cement, so in a traditional fashion. So if you wonder how it works, is that basically cement goes through the cleaning system, and then under high temperatures, measures around 1,500 degrees, you create the cement, and then CO2 will be generated there. So it's an energy intensive as well in terms of CO2 production, obviously. So the proposal here we have is that we would like to see those problematic materials that we have, including Bringley shale that we have here in New Airport in Aeropolis in Western Sydney. So we would like to add treated urine and add the current proposal. The research shows you can add also a bacteria called urease, and then that creates some binder in the soil without actually having the cement addition in there. So urease is an enzyme basically that acts as a catalyst in here that facilitates creation of the carbonates. Probably this is like chemical, although I'm civil engineer, I'm not that great in chemistry, so but this is the mechanism involved. Urea plus water in the presence of the urease, which is a bacteria or enzyme, you can say, creates carbonates, and of course byproducts which are not nice in construction industry, including ammonia and ammonium. And then we will add calcium to this product, and therefore it creates a calcium carbonate, and it would be precipitated inside the soil and creates a natural cementation. Many of the rocks that we have got under the ground, basically, which are strong, naturally have this calcium carbonate precipitated over millions of years. That's why they are strong. And here I can see there is a great potential there. So for the source of calcium that we need to add in there, so I guess to this urine, you can say, so there are a few positive things. So if we lose urea at low pH, unfortunately we cannot use. So when we add the calcium hydroxide, so it elevates the pH. Therefore, as you can see on this graph, the loss of the urea would be minimum. So therefore we can utilize it, and in the same time it creates the source of binder to create the calcium carbonate. And this source at the moment, our idea is creating this one through the lime mixed with water, or in lab with a solution of calcium chloride and sodium hydroxide. So that's how it looks. So there will be a fair bit of mechanical testing in addition to chemical testing. So we're going to test the Bringley shale and break it down to small particles. We're going to test it on loose sand as well, and expensive soil. So we're going to do comparison of this treated urine with urease, and then compare it with addition of the normal Portland cement or general purpose cement, we call it here in Australia, and lime stabilization, and see how good is this treatment compared to the other existing practices in the industry. And the test that we do, again, I understand most of you apparently are not civil engineers, but we will create samples and then crush them and measure the strength of it, but under different conditions that is required by the standards for road construction. We will also do the leachate testing to make sure what is going there through the groundwater flow and so on doesn't create what is not again acceptable. Permeability and so on would be all considerations for road and railway construction as well. So some again ideas to address the challenges of the byproduct of ammonia that we have there is that again some of the research we have done shows that natural zeolite can be added to remove the ammonia. So again, I'd like to learn from the members of the hub more on this. So we can also use the PAA to immobilize ammonia. It's not removing it, but it just stays there in the soil. And also we're going to try the normal drying on site to see how it works. Obviously that releases ammonia, so which is the problem, but we're going to look at it. And the proposal also there that we can work is that we cover the surface of the ground using membrane and control this ammonia. It might be used for hydrogen generation and so on. So remember the scale of the work we are talking about here is we are talking about improving the ground for kilometers or 30, 40 kilometers of road. So the scale is significant. So, and obviously we have done just some basic calculations in there. Obviously there are a lot of benefits in terms of replacing the cement or general purpose cement and reducing the carbon footprint that we have got. And in some of the developing or underdeveloped countries that Australian companies are operating there, such as Pacific Island, they don't have a chance of having the cement even. So, but I'm sure they have a chance of having urine there. So therefore, seems it's possible even to help there. And of course, we need to improve the environmental image of construction industry and move towards sustainable buildings. So here, just as the kind of last sort of slide, I guess, I show we have got 5.3 million of population here in Sydney, assuming each person creates 1 liter of urine per day. We are generating 5.3 million liter per day here just in Sydney. And since this is enough to stabilize the ground for 30 kilometers of road for 2 lane per day of production. Therefore, to somehow, although this is a competition, I guess here, you would like to use it for fertilizer, but we have some use there as well. And this addresses quite a number of SDGs, including the industry, innovation, and infrastructure, reducing inequity, sustainable cities and communities, and so on. So, and partnership, some of them are common with fertilizer, obviously, and some opportunities for collaboration. I like everyone to think is that one is that we are using the enzyme urease. So if there are some other bacteria or techniques, I just had a chat with Stefan a bit earlier today, so might be some other ways to separate that carbonate and then mix it with calcium. So obviously minimizing generation of ammonia or controlling it, if there are techniques we can use, but please have in mind that we are talking about kilometers of road. So, and we can use this technique for other cases such as tailings and concrete break and so on. And the other interesting things that I didn't get a chance to talk to Sean last night, putting this together, I thought is really adding this material or product that we are thinking to the soil to increase the water retention of the soil, which is good for the drought and applications in the agricultural field. On that note, thank you, and I appreciate my co-CI, Professor Kapos, who is also here
And thank you, Mandel.
Thanks, Ms. Allen. I know we already talked, but I just had another thought. The UGO process basically takes the urea, converts it into ammonia and carbonate. Then we get the ammonia out because we want to recover the nutrient. And we have a byproduct which is rich in carbonate, pH close to 10. Could that work? Because you really don't want the ammonia in your system. So it might be better just to work with what we discard already, because all you want is the carbonate.
Absolutely.
What's the ideal pH for the soil to stabilize with this cement?
I think pH of around 8, 9, 10 seems good to me, actually.
So maybe
I think this is fantastic about it. If we can make use of what you're not using even, yes, great. Let's talk more.
Easy.
Absolutely.
Sure. Seems like that's some samples.
Thanks, that's very interesting. I think about you can use your own stabilize the soil, but with and 30 kilometers per day, right?
Per day.
Per day.
2
that's
lanes.
right. 2 lanes.
If it's 4 lanes, it will be 15.
Oh, yeah. It's a fixed rate. You cut the string, put water past it because you dilute it right. So with the ammonia, how long is the release period? Is it quite quick? Like after it's released, the ammonia. I mean, you can have ways to mitigate it, but is it like maybe 1 week, 2 weeks, or does it take years for it to dissipate out?
This is still research to be done. To be honest, I cannot fully comment on that, but I think we are looking at something in the order of weeks to months.
Yeah. So it's just the initial period.
Yes, correct.
It's pretty much
Exactly.
Okay.
Absolutely.
Yeah, it just makes me think of what things you can do in the chemistry point of view to capture the or fix it. You're already looking at zeolites, some kind of acidic materials, which is the classic way to capture.
Absolutely.
No, just a question around, I guess, the concentration of bicarbonates in urine or carbonates, calcium. It's very, very low. So in terms of comparing that to lime, which is like 40, calcium carbonate's about 70%.
Sure.
So you need a considerable amount there of liquid material to be working with to get the reaction that you want. So yeah, the application of putting that amount of liquid into the system, I guess that's going to be a challenge for you.
Yes. What happens is that at the moment, the lime or cement treatment we have is we don't add too much. It might be 5% distributed over a big area. And the current practice is that we don't even mix it with water, although we like to add some water because it makes it more homogeneous. But logistic-wise, it's much easier to bring it to the truck. So in that sense, I guess this is really to be researched. I agree. This might be something we kind of conclude that it needs a lot of urine and concentration there. I agree. But I'm hoping that through this hub, there are ways, to kind of maximize that. But yeah, I appreciate that. Yes, very good point.
Thank you, Reza. Thank you very much.
Thank you, everyone.
That's the end of this last speaker. So we have another 4 minutes that we can discuss. Actually, initially allocated 2 minutes, but we should just. I have few questions to ask to take the speaker here. Okay, so if any one of you have any one questions to our speakers here, we must any question that you want to ask? I just have one question for Dr. Jing Guan. So you mentioned about the lithium recovery, and obviously, when we're talking about lithium recovery from the brine, there are a lot of other ions, competing ions associated with that. So, do you have in your company working on something like lithium ion selective membranes? Because membranes can play major role in this kind of separating process also for the rates of recovery. Obviously, ion selective could be one of the role that can play. So, you have anything in your company that people work doing research on as well?
You mean the memory development?
Yes.
We don't actually,
We have people with the online.
Yes, as we, our company is a membrane technology company, so membrane material development is a key actually in our company. So we, according to the marketing requirement, recently we developed those membrane, including especially for nanofiltration and our system for resources recovery, lithium recovery, also some other wastewater recycling. For any kind of application, actually, we develop the membrane, really focus on that area. So we do have like series of membrane for different applications. So actually, if you have the requirement, we also can do like some research on that membrane as like customized membrane for your group or for your requirement. Does that answer the question?
Okay.
Just a question from Dr. Gao.
So
Yes.
in your NiCE mobile loop that you had, above the toilet, you had this monitor. And I just wonder, what does that do? Like,
very carefully. So, because we see. So we basically mentioned this is a futuristic kind of pilot toilets. What we, because it's still in the design phase, what we try to do is maybe combine some monitoring system. Like this is I think you probably heard about this wastewater based minority kind of thing. So basically from human waste, they can actually tell you a lot of informations, for example, your health. But maybe we don't go that far, but at least we can combine some kind of monitoring technology can give us some additional information. This is our concept, and yeah, we are working. Thank you.
Maybe we can drive the caravan over your bad roads. Just on the top. Stabilize the road.
Thank you. Thank you, Mr. President. So I think we'll have to break for tea now. We'll resume at 3:40 here for the next session. And we want to thank everyone for their presentation. Thank you very much.